Good evening and welcome, everybody. This is episode 4 of Check-In, brought to you by the RoboSports Network. I'm your host tonight, Francis O'Rourke from RSN, and I'm very excited to get to bring you here to have an inside look at some of these awesome teams we've got working with us. Before we get started, I want to thank this show's sponsor. They've been doing a great job for us. It's Andy Mark. You know them, you love them. They got a lot of great products. If you don't know about them and you want to build a robot, check it out, andymark.com. They're a supporter of Check-In. And thank you guys very much for helping us out this year. I also want to thank RSN's primary sponsor, Symbotic. I'm live from the Symbotic offices in Montreal, actually. I'm on here for business. Symbotic is a warehouse automation company. They do a lot of awesome stuff. Check them out at symbotic.com to learn more. All right, guys. So we've passed the halfway point in the build season, and teams are actually starting to make stuff that moves. Woo! Awesome. We'll be bringing each of our 6 teams on one by one to discuss their week. And then we're going to do a brief intermission between each group. So when we go dark, make sure you stay tuned because we'll have them right up maybe 1 or 2 minutes afterward. Also, we're going to be doing a Q&A during the show. Down below, you see the question box. We're going to ask for questions from the chat. So if you have them and you're watching on Twitch, just type !Q followed by your question, and we'll send it right in. All right. So first up, it's going to be team number 319. We're going to bring them in and show their video that they made this week. So let's take it away and see their awesome video.
Working on the drivetrain rail, and we're doing a chain and tube. So I'm CNCing an 1 1/8 hole.
That looks fun. What are you guys doing?
We're trying to convert our motion profile to command base.
All right. Great video, guys. Saw a lot of awesome stuff there. So again, I'd like to introduce Team 319. They're Big Bad Bob from Alton, New Hampshire. Why don't you guys introduce yourselves to everybody?
Hi, I'm Jamie Westlake. I'm a co-captain, and I machine things.
Hi, I'm Nicholas Nethery. I'm part of the build team. I'm a sophomore.
I'm Tim Geyer. I'm a programmer. I'm a junior.
Cool. Well, welcome to Check-In, guys. Good to have you. So let's talk a little bit about what you guys did this week. So go ahead and give me a sit rep. Where are you guys at? How is the whole project going so far?
Right now, I've done a lot of machining, so We actually have a frame, and just today I finished a frame for our shooter, elevator, and climber.
Awesome. That's are you guys ahead of schedule? Are you behind schedule? Are you just where you need to be? What's your take on where you are right now as far as the whole season's concerned?
I feel that we're on schedule.
Okay, cool. You feel like you're on schedule? Does that mean do you guys have like a calendar with deadlines for your systems, or you just kind of going as best you can?
I don't know. I'm just
Pretty much
guessing.
going as best as we can right now.
That works.
Just with the progress we've made, it seems like we'd be on online or on track.
Everything's been going remarkably well so far.
Well, that's great. Hope it continues. Hope we didn't just jinx you by accident. That would be bad.
Yeah.
So let's talk a little bit about what the next step in your season is going to be. So what do you guys have left to do? It looks like you've got your CAD model is pretty far along. And it looks like you're building a lot of parts. Tell me what's up with the rest of the physical robot as it goes forward.
Oh, you want to do it, Nico?
Yeah, right now we're working on finishing up prototyping with gear pickup and gear collecting, trying to figure out the best way to do that and the design that we're going to use. We've basically got our everything set for the shooter and climber and elevator. It's just we got to finish up with the gear collecting and pickup.
Yeah, and on the programming side, all of the shooter and the elevator all have already working on closed loop control. So we've already got all that stuff squared away in our code right now.
Oh, cool. Awesome. So let's talk a little bit more about actually the control stuff, because we've been focused a lot on like what the robot's going to look like and what the prototypes are doing so far. Why don't you tell us a little bit about where you guys are as far as controls are concerned and like programming and all that stuff?
Okay, we've actually been doing really well so far. So we started out with the basic priorities of getting our drivetrain running, and then with prototyping, we got our shooter running on a closed loop, and we got our elevator feeding the balls into the shooter running on a closed loop. Since then, we've been working a lot with motion profiling for our autonomous, and we've been using a spline generator, which you put in an X and a Y and a rotation value, and it actually makes a track for your robot to travel in autonomous, that 254. It's 254 code that we've been using and modifying.
Wow. So is that like that graph we saw in the video earlier? Is that basically what that is?
Yeah. It's like 2 lines, and it shows you how the robot's going to move.
Wow.
We've been doing a lot with that.
Can you give me, because I'm actually really curious, can you give me the basic lowdown on how that works? Is it used like encoders, or how does it figure out the path?
So it uses encoders. You feed your encoders actually are calculating their value off of your drivetrain width and length, your gear ratio, and you give it a maximum velocity, you give it a maximum acceleration, and you give it a distance, and then you give it points that it has to travel to. And so, like I said, we have an X, a Y, and a rotate value in radians, and so the points are all in feet. So we say we want to go 5 feet forward and 5 feet to the left. We would put 5, 5, and then we'd put a rotate value for whatever angle we wanted to turn. And it would actually spit out a graph showing 2 lines where the drivetrain wheels would be, showing how the robot would travel.
Wow. It does all that math for you. You don't have to like program in all the crazy stuff for it.
Yeah, it's been very nice to be able to have it do that for us.
Very cool. Awesome. So what about vision stuff? We know that there are retroreflective targets on the field so that teams could use a light to track onto them. Have you guys experimented with that at all, or do you have any results with that?
Our vision has been mostly driver oriented, with the driver being able to see around at parts of the field that he won't be able to see. So we have a camera working, and we've been doing drive practice with the backup test robot with the prospective drivers. And they've been using the cameras to just try and operate in situations that might not be the most ideal. As for vision processing, we haven't quite gotten to that yet.
Okay, cool. I guess it makes a lot of sense. If you guys are going to be shooting from right up against the boiler, so you don't have to aim very far to get your balls into the goal either. So
Right.
Cool. All right. So any other cool, awesome controls related stuff? Any cool, nifty sensors or other cool things you guys been working on so far?
So this last Saturday, we actually had a rookie team come down to good old Prospect Mountain from Brewster, which is a private school. And this is their first year, and we got them all set up, which has been a lot of fun. We got their their code put over into command base. We got their Robo Rio configured, and we got their drivetrain and climber working.
Oh
while they
wow!
were here. So we helped them out quite a bit, and it was a pretty rewarding experience, I'd say, for everyone.
Yeah, we definitely helped them go in the right direction. You know, we gave them some pointers and stuff on like what to do on the rookie year.
Awesome. Can I ask for those who don't know, where's Brewster Academy?
Brewster Academy is in Wolfboro, New Hampshire.
Okay, so it's like half an hour away from you guys or so.
Thereabouts.
20 or all right, yeah, half an hour.
Okay. Cool. What team number are they anyway?
6691.
Cool. Well, shout out to Team 6691. Hope you guys are doing better. Can't wait to see you guys at the events too. That'll be awesome. Cool. So now that we've talked a little bit about all those ones and zeros, let's talk a little bit about what you guys have built so far. We know you guys talked a little bit about it earlier. What have you guys finished so far as like manufacturing? How's that going? And I know you guys built 2 robots. I kind of want to hear how you're using the 2 robots. You building both at the same time or then one and another? What's up with that?
So we're building both robots at the same time. So right now I have one of the frames. You can see it pretty well there. And yeah, so we have 2 of these done. So we're just all building them simultaneously, and once they're all together, we're basically gonna give one to build team and one to the programming team, and then we'll switch them off like every week.
Okay, cool. So it looks like that's one big weldment, right? So who did the welding on your robot? Did you guys do it, or did you guys have a sponsor do it, or?
Our lead mentor, Heichel, did it.
Oh, cool.
We don't have any students that want to weld, and he's pretty good at welding.
Okay, cool. That's awesome. That's good. It's great to have that kind of facility at your disposal. That's good.
Yeah.
Cool. So good to see your frames are together. What else have you guys been up to? I know you guys we saw some spinning wheels in the video. What's that all about?
That's our drivetrain rail. That was from last week, because last week I actually brought that on and showed that.
Okay, so just more of that basically.
Yeah, we haven't put our wheels in the drivetrain yet, but.
Oh, okay. So that frame member is actually welded into that whole weldment you just had.
Yeah.
Okay, cool. Neat. All right. Well, that sounds good. Anything else? You guys are in the middle of building? Anything almost ready to test or assemble?
You said you're doing gears, right?
Yes, I was.
Yeah, you mentioned that already. Oh yeah. So probably this coming weekend we're planning on being able to drive.
Nice.
So, we have a little bit of a schedule, I guess.
Cool.
But not really much of a schedule. I think we want to get driving as soon as possible, basically, so that everybody can get used to the controls on the robot and how it drives.
Okay, cool. So let's kind of shift gears, not to actually just talk about gears, but let's kind of shift gears a little bit. Talk about some of the not robot stuff you guys have been working on. I know we saw in your video that there was a chairman's presentation that looked all marked up. Why don't you guys tell us a little bit about that? And if you guys are, I don't know if you guys are involved with the chairman's presentation too much or chairman's essay. What's like the gist behind it? Do you guys have a story you're telling, or what is it?
Well, I don't think any of us have worked on it very much, but I've looked at it a few times, gone through it. It's sort of more or less what we've accomplished throughout the years. Some things that we do every year, like Battle of the Bay, our own off-season event. Just a lot of the things that we do to contribute to the community.
Okay, cool. So any other kind of like awards or other kind of stuff you want to talk about in that realm?
No, I don't think so. I like the three of us honestly haven't looked at it very much.
Okay, that's cool. That makes sense. It's fair enough. Cool. So, it's past halfway. It looks like you've got a CAD of your robot, an almost full CAD. Is that right?
It's a full CAD.
Nice. So, but except I saw a little circle for the electronics. Is that serious, or are you guys kind of just playing a goof with us?
Uh, that picture is late, or it's old, I should say.
Okay.
Um, yeah, that's old. So there is more space now that we've done some adjusting in the back with supports.
Okay. So you will be able to fit a battery and everything.
Yes, yes.
Cool. All right. Well, I think we're coming close to the end of time, so we're going to bring up some questions here. We have, again, if you want to ask a question of these guys, just go ahead and type !Q followed by your question in the Twitch chat, and if we like it, we'll bring it on air to ask these guys. So let's bring our first question up on the screen for everybody to check out. Here we go. Why are you trying to convert your motion profile to command-based? Is that true? Are you actually trying to convert your motion control file to command-based?
Yep. We run all of our code on command base.
Okay.
So we don't want to have any weird outlier code that, while necessary, is in a different form than the rest of our code.
Okay. And how's that been working so far?
Pretty well. Converting motion profiling to command base has not been a simple task. We've needed some help from our mentors, but it's gone very well. We actually had a motion profile working about 10 minutes before the show started that was converted over to command base.
Sweet. So for those who maybe don't know, can you kind of explain what command base is?
So command base uses almost like a 3-point system, where you write methods in the subsystems of your code, and you use commands, which are a different part of the code, to refer to those methods, and then you map those commands to buttons in the OI, which is like your controller. So command base is just instead of it all being in one place, it's in 3 different places that are all connected and all work together to get the same job done.
I see. Okay, so it's not like doing functional programming, like building functions and adding them to one big loop. It's like having 3 discrete areas that sort of interact with each other in specific ways.
Yes.
Okay, cool. I guess that is kind of makes it a little bit easier to build up. So
yeah, it makes it easier to know what's going on.
Cool. All right. Well, I think we have one more question we got coming up. Let's put that up on screen. Thank you for your last question, Bartholomew. We got another one coming up here. All right. Is your team planning to have gear ground pickup? How relevant do you see that capability being in different levels of competition? So, what are you guys' thoughts? Are you guys doing gear ground pickup with the gears?
Yes, we are. That is what we're based right now. We're working on is ground pickup, and at the same time being able to have almost an envelope that can catch the gear, and then if need be, pick it up off the ground. If say there's a gear dropped by another team, or missed the envelope, just as a backup in case there's any gears in the ground, and we had the ability to get them.
Cool. So I guess the question is, do you guys think that ground pickup is that important? I mean, I know that there's the capability, but like, do you think it has value later on in the competition at like higher levels of the event, or do you think that it's kind of just a cool feature?
I think it'll be very important, because if you need that one more gear and you don't have the time to go all the way to your pickup or hopper, and it's there, and you have the ability to get it, it would really help your alliance or team get that last gear quicker and faster.
Okay, cool. Good answer. All right. Well, gentlemen, thank you so much for joining us again this week. It's always fun to talk to you guys. Everybody else watching at home, we're going to take a very brief break. We're going to bring on our next team. Next team coming up is Team 3940. There's Cybertooth from Kokomo, Indiana. But for right now, I want to thank you guys, Big Bad Bob, 319. Thank you guys so much for coming on, and we'll be right back. Bye-bye, guys.
Yeah, see you.
See you.
See ya.
to the beach, let's go get away. Night, second, we'll check on us there. Have a drink, down the Bud Light then.
Alrighty, everybody, welcome back to Check-In. Our next team up is 3940 Cybertooth. They're from Kokomo, Indiana. Welcome back, guys. Good to see you. Can you guys introduce yourselves for the people at home?
Hi, I'm Gustaval. I'm team president.
And I'm Lucy Baker, and I am a freshman this year.
Cool. Well, welcome to the show again. Good to see you all.
Yeah.
So let's get started. Let's talk about all the cool things you guys have been up to. So first off, let's get an update. We saw some video in there. Tell us how you guys are doing as far as building the robots concerned. Where I know that we saw some looks like some maybe prototypes, maybe production stuff. What's up? What's going on?
Well, we're kind of gearing in on the stage where we are finalizing all of our designs, getting everything catted. So pretty much all of our subsystems have taken shape, and we know what we want from them. It's really all a matter of getting parts built for our first practice bot right now.
Oh wow, cool. All right. So you're going to build your practice bot first, then build your competition robot after that one's done?
Yep, that's the plan.
Yeah, we're doing a lot of manufacturing right now where we're actually making 2 of everything, so that way we can, we're making the practice bot first, but we also have a jump start to making our real one.
Okay, so you only have to change the parts that are different, basically.
Yeah.
Yep.
Okay, cool. All right, so let's talk a little bit about that then. So you mentioned that your mechanism is starting to look like, looks solid. So what is what are some of the parts of your robot look like? We know that the shooter has been a kind of a question mark so far this season. It looks like you guys have a more solid idea. So tell us a little bit about that.
With our shooter right now, we're looking at, obviously with our turret, we want to be able to shoot from different angles on the field. And so we had to solve the problem of a very small hood and super high RPM for shooting straight up. And so we're working on getting the wrap so that we have enough to shoot the ball directly up and get it into the boiler right in front of it. And we think we found a way to do that by basically feeding the ball up under the wheel and then back out rather than just straight up into the flywheel.
Oh, okay. So it's coming like at the bottom of the wheel and making like 180 degrees worth of, or well, not quite 180, but maybe like at least 90 degrees of wrap around the outside.
Yep, that's the plan.
Yeah, we had some issues before because we were planning on doing it over, but the way that the geometry worked out, we would have only had like 10 degrees of wrap, which would not have been enough at all.
So, no, I don't think so.
Yeah.
let's talk a little bit about that. You guys mentioned to us before the show started that you guys have been working through all the bumps in the road that comes with any sort of big project or build season. Why don't you guys tell us a little bit about those?
A big problem that we had right off the bat after getting some of our prototyping done was just issues with CAD, making things. Our intake has really taken shape on our robot in CAD, and that looks really good. And initially that didn't fit, but we got it to, and so it's going to be pretty cool.
I mean, we definitely had a lot of spatial issues just figuring out what gets more space, and we've prioritized that fuel gets a lot of more space, but a lot of the teams had to cut back on what they had, especially, I know Gears, each time we make something new, we have to cut back and have more restrictions, but we're making it work, yeah.
Cool. Yeah, it's always a challenge to figure out exactly how everybody's system is going to come together. I know we saw some of your prototypes that were not some of your stuff going on there. It all looked really, really tiny. Is that kind of the feeling you're getting this season, that the robots are going to be teeny tiny robots compared to previous years?
Hopefully small, but well designated with space.
Yes.
We're working on consolidating or using up all of the space above our over the bumper intake to get those extra balls and stuff. So our robot looks pretty tiny in prototyping, but reality, we've got probably 30 plus balls stored in our intake at any time.
Oh wow, very cool.
Yeah, it's pretty big.
Nice. That's awesome. Cool. So we saw a little bit of footage of that, of you guys building and actually constructing some of the robot. And Lucy, you were just saying that you guys are like in the middle of the heavy manufacturing process. Why don't you tell us a little bit what that's like for your team? What kind of resources do you guys have available? Is it mostly sending out sheet metal parts, or do you guys machine parts at your shop, or do you guys like just have a drill press and a bandsaw? How does it all work for you guys?
Well, we're machining a lot right now, especially the drivetrain, and they're just making all the pieces right now, mostly on our lathe and mill, but also on saws and different presses, and also people are just creating things by hand, like working on motors, different things like that.
And we've also got an in-house router here at Andy Mark that we get our parts run on there to get the general outline of the parts, but then doing some of the more specific holes we do on the mill and stuff.
Nice. Is it like a big sheet router, or how big's the bed on it? Like really big, or?
I'm not sure the exact dimensions, but it's pretty large. We can get a big robot run out of each time we run it.
Very cool. Sounds fun. All right, cool. So let's talk a little bit about as we go into this. We've talked, again, like I said before, we've talked a lot about physical robot stuff. We haven't talked so much about the ones and zeros. So tell us what you guys' plan is as far as controls are concerned. Doing anything cool, doing vision stuff? What kind of sensors are you guys using on your robot? Let's go into that a little bit.
Well, right now we've got a programming team of about 6 people. A lot of them are new this year, and so they're kind of learning as they're going, but they're doing a really great job of working on vision for the turret on our robot, if we can pull that off. So we're working with some pixie cams to try and track the goal. That's going pretty well. We've also looked at pixie cams for a gear auto, as well as the basic encoders and sim coders for shooter and drivetrain.
Yeah, we're doing a lot of, they're actually using our old last year's practice bot, and so they're working with that to do things like counting how many balls are in the shooter and accuracy, different things like that.
Yeah, and then also our controls subgroup is meeting with the rest of the subgroups to talk to them and see what kind of sensors they need to integrate into their code for when we get the final robot done. Because this is really the first year that we've had the programming team be able to work on stuff like this early. So it's been really nice.
Awesome. Yeah, that's always a hard one. So do you guys, I guess maybe this is a mixture of both perhaps, but do you guys come with the philosophy that the programming team dictates what sensors the mechanical team has to implement, or does the mechanical team sort of drive the sensor usage that the programming team has to sort of make work?
It's really the controls team, like the programming and electrical, that decide on sensors, and then they communicate with the mechanical what kind of sensors would be best for the mechanisms they're using. So the controls team are really the ones that decide that.
Okay, cool. I mean, that makes a certain amount of sense. You know, you got to make sure that the people who are going to be doing the code know what's up and make sure the right stuff is used. Okay, that makes sense. Cool. So a lot of encoders, a lot of vision stuff. How's that been working for you guys? I know you guys said you're going to use it. Is it looking promising so far, or is it still in the early stages?
It's still in the early stages, but it does look promising.
Okay, both.
Yeah, they're making progress pretty fast on the vision tracking, so it's going well.
Yeah, we're in a really happy place somewhere we are, because in previous years we just haven't had this much of a start at this time of the season. So yeah, we're very happy.
So I got to ask, what do you think's made that possible? What have you guys done differently this season to give you more time with the programming?
Well, some of the prototyping that we've done, we got it done right away, as well as also using last year's practice bot to test things, because we already had all the talents set up on there, so they were able to just get a jump start and test the sim coders and other sensors on it. So we didn't have to wait till we had the actual practice bot to test the things that could be done on any robot.
Okay.
Also, our lead mentor, who's in charge of software, he was working on before making a camp for the kids who are new to programming this year, so that way they had an idea going into the build season of what they were going to be doing.
Oh, okay. So you trained everybody up before the season began, so you weren't starting from zero when it was time to start actually building the robot.
Yeah.
Cool. That's a really good idea. I know it's something that my team, we always try to do, but it never seems like it's enough, especially because the build season's so hectic sometimes, but it's great to hear you guys are doing that. So you guys were talking about how you guys have 2 robots. You're starting to build parts for both these robots at the same time, and especially because you're gonna maybe have some of those parts become obsolete when you revise your practice robot. How are you guys tracking all of that? Do you guys have like any sort of system that you use to make sure that the right parts are in the right place?
Yeah, actually this year we kind of developed a new parts numbering system for our team based off of our 2015 parts numbering system. And so basically we're keeping very close track of each part that is manufactured, by whom it's manufactured, and where it's at, like in the shop. We've got a specifically designated area for machined parts and parts that will go on the robot. And so we're keeping everything very, very organized in our Google spreadsheet as well as in our shop.
Oh, cool. That's awesome. I might nerd out a little bit about this because that is like literally my job. I do document control for a living. So that's kind of really good to hear. And is this born out of some problems you found last year? Because you mentioned 2015 you used the system and you're using it this year. What happened last year that made you want to use it again?
I don't think we had a whole bunch of problems last year with it. It's just we found that it was a lot easier to talk to judges and show them what was up with our robot in 2015 when we had that. And last year we didn't really get a good get-go from the start on the part tracking. And so it's good to have it started earlier this year.
Oh, okay. Cool. That makes a lot of sense. Nice.
It also helps like to identify different parts. Like if you have two pieces that are really similar in size, and that way you can be able to distinguish them, or even from spare parts that people just have leaving around. So yeah.
Yes, I can't tell you how many times I've seen what looks like an innocuous washer or just a piece of junk on the table, and I've thrown it away, and someone's like, "No, that's my part."
Yeah. Yep.
So I assume you guys do like write the number on each physical piece as well, so you don't lose it.
Mm-hmm.
Cool. All right. Well, that's very good control of your material. That's good to hear. So let's also talk about something that maybe not a lot of teams are thinking about because it's so early in the season. But let's talk a little bit about scouting. You guys wanted to talk to us about this year. So do you guys have a scouting plan, or how's that all going to work? How are you guys? So by the way, for those who maybe don't know, scouting refers to basically at competitions getting data or observations on other robots, so you know who you're playing up against and who you're going to be picking. So tell us a little bit about your scouting plan this year.
So we've got two very experienced scouting leads that have already gotten a jump start on what we need to have for the season. And so our first concern was basically counting game pieces scored, just because it's going to be such fast-paced gameplay. And so we're kind of looking at more like qualitative ways of measurement for scouting, like looking at, say, how many cycles they were able to get, and if they scored a lot of balls, or like if they look like they're pretty accurate. So we're working on tuning that in more, but we've got some really experienced and great people working on it, on our whole system for that this year. Okay,
cool. So you're not really looking at it from a big data perspective. You're not trying to get as much, just gobble up as much data as you can, but you're trying to take you're trying to leverage the experience you have and sort of use it better with the rest of your team.
Yeah.
Okay, that makes a lot of sense. Cool. So do you guys know how you're going to be collecting that data? Are you going to use like a paper sheets or an Excel sheet or a cool app on a phone or something? Or
in past years, we found a lot of success with just solid paper scouting, and then a scouting meeting at the end of each night to consolidate all the data. So yeah, I think we're going to do paper scouting in the stands and then compile all that for our pick list.
Okay, cool. That makes a lot of sense. All right. So by the way, if anybody has any questions for Cybertooth, you're welcome to send them in by typing !Q, followed by the question in the Twitch chat. And if we like your question, we'll ask them to him live on air. So I think we're going to start off by asking a question in just a second. But again, if you've got more, send them on in. So I guess the next question for you guys, before we go to ask for the chat, is where do you guys think you are in the season? Do you think you're ahead of schedule? Do you think you're on schedule? Or do you think you're not on schedule? We'll say that in a positive way.
Well, I think that we're slightly behind schedule, but we're in a really good place where we're getting parts made, and we're still working on CAD, but we're getting the final touches in before we can really start going full-fledged into creating our robot. Yeah.
Mm-hmm.
Cool.
Yeah, we most of our sub teams are doing pretty well. A couple of them are ahead, like our gear group and our rope climber group are both very well off where they're at. But then fuel group and drive team, which are our more important tasks, we've spent a little bit more time on just to make sure those are more perfected so that we can really get what we want out of this robot. So it's been paying off. Things have been going well with that. So
Cool. Well, that's great. And I know that, like, I would say most teams are probably behind where they want to be. So, and it's good that you guys have a plan going forward to make sure everything ends up on time. So it's good to hear. All right, let's take our question from the crowd here. Question coming up first here is, all right, this is coming from Twitch chat. Why do you build 2 robots if you can only compete with one? This is a really good question that I think a lot of first people kind of take for granted. But why don't you give us and the rest of the folks at home a little idea of why build a practice robot at all?
One of the really big reasons is driver practice. In past years, we found that leading up to if we have, say, a week 1 or week 2 event, we don't get enough practice in just because we're so pushed down to the wire. And so if we have that practice bot that's identical to the bot that we're using in competition, and the competition bot's already bagged, we can still practice and test things that we can implement at competition when we have open bag time.
Also, because we're making our practice robot first, we're able to perfect things and figure out what we're going to do more quickly. And even if, like, on our practice robot it's kind of messy, we'll have experience doing that, so that way it'll be perfected for our real robot.
Mm-hmm.
Oh, I hit the wrong button. That's almost like a beta test, basically, or a prototype before your real robot.
Yeah.
Mm-hmm.
Okay, cool. That makes a lot of sense. All right. Well, guys, thank you so much for joining me once again on Check-In. It was great to hear from you. Great to hear about your team. I can't wait to see where you guys are next week. Next up on Check-In is Team 2337. It's the Engine Nerds. They're from Michigan. They're going to be joining us here. We're going to take a very quick break and come right back. But for now, Cyber2, thank you so much for joining us, and we hope you have a good week. Bye-bye.
Thanks for having us.
Thank you. All right, welcome back, everybody. First, I'd like to introduce our next team here for check-in. It's Team 2337, the Engine Nerds. They're from Grand Blanc, Michigan. Why don't you guys introduce yourselves to everybody at home?
I'm Clinton Bollinger. I'm one of the co-lead mentors of Team 2337.
I'm Alexis. I'm co-team captain and operator interface student section leader.
I'm Gus. I'm the head of communications and a senior programmer on the team.
Cool. Well, guys, welcome to the show. Thanks for coming on this evening and talking with us. So let's no problem. So let's talk a little bit about how your week's been going. Give us an update as to where you are for this week.
It's been going pretty well. We've accomplished a lot of our goals. So we got a lot of machining that we wanted to do done last weekend. And then last night we were able to send off some of the parts we want to WaterJet. So it's been going pretty well this week. Our main goal for the end of this week is to try to get a practice robot ready that has our gear intake on it, a field intake, the gear mechanism, and the sides. That way we're able to get a moving chassis and try to practice driving, that kind of stuff.
Wow. So you're gonna your plan is to already have a robot like doing most of the game by this weekend?
Absolutely.
We hope so.
Wow.
The only thing we'll probably be missing is probably the shooter and fuel tank for our robot itself.
Cool. Wow, that's awesome. So I got to ask, how achievable do you think that goal is? I know you guys said you met your goals for this weekend. Is there lots and lots to do? Is it going to be a push to the end to get it ready, or you guys think it's going to be a shoe in?
I think that with what we have so far, that at least for the most part, we'll be prepared for bag day. Definitely.
Well, I mean, WaterJet should be back tomorrow.
Okay.
So with our WaterJet, we have two robot parts going out. One of them will come back to be sent off to powder coat, as well as our competition chassis sent off to powder coat. And so this weekend will be electrical wiring. The intake is already machined. They're actually assembling it downstairs right now. And then we got to do a lot of work on the climber and gear mechanism, but hopefully by the weekend we'll have that going.
Cool. Well, I mean, that'll be good. And you'll have a platform to test it on and see how it all works out too, and make improvements for your final robot. Very cool. All right. So let's talk a little bit about, now that we've got an idea of where your robot is, let's talk about the software and controls for your robot. So what kind of sensors are you guys using? How is your robot gonna navigate the field and control itself? What maybe are you using vision at all? What's you guys plan so far for the year?
So right now, we're using a lot of different sensors. We're using mag encoders, which is like magnetic encoders. We're using cameras for vision. We are going to be doing vision. We're using different gyros. So last year we used Navex, and this year we're kind of testing different gyros, like the internal on the RoboRio, and Pigeon is another one that we're testing to see like which one would work the best. We're doing like testing on that right now.
Interesting. So why Navex? That's got like a lot of bells and whistles on it, doesn't it?
Sorry, you're buffering a little bit.
Oh, sorry about that.
So I think what your question was. We used the Navex because there was some calibration. Like it took care of some calibration for sensing the position. Also, it plugs directly into the MXP port, I think is what it's called on the RoboRio.
Yeah.
But like I said, we just want to look at it to see which one's easier, more stable, and gives us the best results. So we're trying all of them. We're not counting any of them out.
Okay, cool. Sorry about that, by the way, guys. Didn't mean to make my voice go all crazy on you. All right, that's good to hear. So let's talk a little bit about vision. Where are you guys as far as vision is concerned? I know that it can be a complicated problem. I don't know if you guys have used it before in the past. Why don't you tell us about how that's going?
So last year was the year that we really started messing around with vision and using grip to help get the images all set and ready for our code. And this year it's been going a lot smoother than last year since we've learned from our mistakes. So we actually have some very key points of it done. So it's mostly just taking the information that we get from vision and using another code.
We can see green.
Yeah, we can see green. Lots of green.
Lots of green. So for those of you who maybe don't know or are watching, can you explain what grip is really quick?
So grip is like an image processing software. So if you take a video of what the robot sees, you'll get all this background stuff you don't want. You just want to see the goal. So what Vision does is it will sense the retroreflective tape. It'll darken anything else in the image other than that. So then all your robot really sees is the retroreflective tape. And a lot of teams use LEDs with green strips on them. So when the lights flash to the retroreflective tape and flashes back, it generates this very bright color, this bright green goal in sight. So Vision just processes that. It can also tell you your center points too, which is very useful. We're using that right now as well. It tells you area, so you can do a lot with Grip.
Cool. So I guess the next question is, what exactly are you guys going to be using Vision for? Are you going to use it to line up to the boiler, or are you guys going to use it to line up to the gear post where the tape is down there?
So right now we're focusing more on lining up with the boiler. So we're just messing around with that. We're more focused on shooter stuff, as like what we did in the beginning of the year with our strategy dictates design. So we've had that down pretty well, and now we're just implementing like gyro code with it, so then we can like turn with whatever Vision tells us to do. And yeah, just messing around with different drivers to see like what's the best thing to use.
Cool. All right, that sounds good. Any other neat stuff you want to talk about with software before we kind of move on to another topic?
Well, there is something that we've been using. Usually a lot of teams use PID loops, which help keep certain things at certain set points, depending on like if you want like displacement or like speed set points. This year for our shooter, we've been working with this code. I don't know if it's officially called this, but like bang bang drives. So yeah, so basically it's instead of like you set a set point in the PID, it's you set wherever you want your speed to be, and if you're below that speed, then you crank it up to 12 volts, like the maximum amount of power you can. And if you're like too far above, then you just cut it in 0. And that's been working surprisingly well with us.
Huh, interesting. So I got to ask, a lot of times people think of bang bang control as sort of like a step back from PID. What led you guys to want to go in that direction this year?
Well, with PIDs, it does get very tedious to try to calibrate that, and it takes a lot of time. But we kind of saw it as more of a time constraint with PIDs. It seemed like it was taking like a very long time. We wanted to have like very quick results, so we tried out the bang bang drive, and that seemed to work very well with recovering from like ball loss.
Another thing is, I think some PIDs, I mean, I know you can change a lot of things with it, but some will put on the brakes if you go too far over. Where this, it basically uses the losses in the wheel to come back down to speed instead of putting the brakes on to take you to that speed you need to go to.
Oh, I see. That makes a lot of sense. So you basically, if the wheel is not at power, it's because you're shooting. So you want to crank up as much voltage as you can to get back up to that speed, because you're losing wheel speed by shooting the balls.
Yeah.
Cool. That makes a lot of sense. All right. Well, let's talk a little bit about the not robot stuff. Let's talk about your chairman's award for this year. We know that you guys do a ton of awesome stuff with a bunch of teams in Michigan and a bunch of other stuff. What exactly is your essay looking like this year? Do you guys? I know some teams sort of have a story that they sort of tell with their essay, or they have a theme that they follow. How are you guys doing it this year?
So what's really neat is this is our 10th year of being an FRC team. And so we're kind of going back to our roots. So when we started the team in 2008, our team name is the Engine Nerds. We wanted to kind of recreate the stereotype around a nerd and show how it's cool to be a nerd. So we're doing a lot of that, breaking down in our essay to try to show the things that we do and how they correlate with how we make it cool to be a nerd again, like we said back in our first chairman's presentation in 2011.
Wow, that's actually like a really inventive. I like that. It's very like cohesive with your team's theme. Can you give me like a little like taste of what the essay looks? I'm not asking you to read the essay or anything, but like how does it all flow in a practical way with the essay? Oh, could you hear me?
It was
Say that again.
Yeah, it was buffering a little bit.
It's all right.
You sounded like Mr. Roboto.
Yeah.
Oh, sorry about that. Why don't you tell me, like, give me some examples that you guys use in your essay about how it's cool to be a nerd.
So some examples that we use are, for example, some say like nerds wear glasses, right? So we tie that in with our safety glasses. So we go in to talk about our safety program and things we do with safety. So we gathered as a team, and we tried to come up with some of these names that some people say are true, but we obviously know are not true. Because even though what they say is a nerd, everybody's different, that kind of stuff. So we're trying to defy that stereotype within our paper. So it's a lot of different characteristics like that. Some maybe personality, that kind of stuff.
I think another good example is a lot of people don't like to be actually name themselves after us, and they call themselves the nerdlings. So they actually took it upon us, and they kind of look up to, I think, the high school students as role models, and they aspire to be like them. So
very cool. Well, that's awesome. I hope you guys do well with your essay. I know you guys have won the Chairman's Award in the past, so knock on wood, good luck. You guys have another, I think it's going to be due right like the couple days after check-in, right? I think it's due the 7th, or when is it due? The week? Okay,
the
cool.
9th.
The 9th.
The 9th, that's right. Okay, cool. I'm not writing it this year, so I don't remember exactly, but cool. Well, I look forward to hearing more about it next week and how everything turned out. But what about like the other awards you guys do? Let's talk a little bit about how you guys are preparing to do other awards this year.
So some of the other awards we submit for is the Woody Flowers Award, which is where you nominate a mentor. It's very student driven. We're finishing up some final touches with that, and that will be submitted tonight. That way we can really focus on our chairman's essay some more. For the first time since 2013, we are also submitting for the Entrepreneurship Award this year, which is where you submit a business plan with your 5-year goals, that kind of stuff. And then we also, for each award that we submit for, to help with like the engineering inspiration and chairmans, we make engineering notebooks for both that include like our CAD drawings and design reviews that we do every Monday.
Very cool. Wow, that's like a very comprehensive plan you guys have going on. I like it. I don't want to pry too much into the particulars, but do you guys keep who's being nominated for the Woody Flowers Award a secret, or is it kind of like a known thing across the entire team?
We try. All the students write it. We get some mentor. We get like a mentor that we keep it a secret with them to try to read it over and edit it. But really, it's a lot of the students' opinions that go into it because, it's about us trying to nominate a mentor that we really see as really a star mentor and that really inspires us. So we try to keep it a secret and try to make it as much student-led as possible.
Cool. I really like the way that works. So that's why we do it. How we've always done it on my team. And it's led to a couple of really good moments. So cool. So let's round out our talk this evening about scouting. We talked a little bit about it with Cybertooth, and you guys, we're getting surprisingly close to week 1 and actually competing. So how are you guys going to be judging the other robots on the field this year?
So what we decided this year is to have scouters scout each robot on the field. We're also going to have scouters for the pilots too, so we have sheets for that as well. So we're looking more about like cycles that the robot can do with gears and fuel. We'll mark to see if they can put on a gear, if they drop gears. Also, they can successfully climb or not, which is a big thing that we're looking at.
I was going to say we went through probably, I think we're on like revision 4 or 5 of our scouting sheets. We kind of at the beginning saw that trying to actually in normal games last year we'll mark every shot made, every shot missed, and track that. It's really unrealistic to try to do that with this year's game, with the fuel being 600 fuel on the field at any given time. So we've kind of had to take a step back from that and try to like Gus has said, look at cycles. How often do they go to get a gear to get, fuel off the ground, or, any of the other stats there. And we normally have 6 scouters to scout each robot. Yep. And like I said, we're going to have 8 scouters this season, 6 of them watching robots, and then 2 watching each of the 2 platforms and watching to see if you drop that gear or if you drop the rope.
We'll be watching.
You will be watching. I got So
I mean, to actually touch on that point too, we actually finished our gear slide mechanism this week. Like we made 3 real ones, like out of steel and HDP and all of that. Maybe we'll try to get some pictures or photos of it and for our next video. But there is nothing retaining the spring in the slide mechanism to prevent that from actually coming all the way out the top and falling out. Like it's just gravity and the skill of the pilots. So and then the rope itself can also fall out the port and you can no longer use that anymore. So
yep, it's a very technical skill this year, and that kind of ties in a little bit to a question we got from one of our viewers on Twitch. So let's put the question up on the screen. So they're asking, to what extent do you think that picking gears up off the floor on the field is essential to performing well in matches? So do you think that picking up off the floor is going to be super duper important, or do you think teams are going to be able to skate all the way up to Einstein with just a hop delivering from the loader?
I think that it'd be a useful trait. I don't think that'd be something that's like mandatory if you want to get to Einstein's. I'm sure that they'll have teams that just have your very basic ways of just holding a gear and just cycling with that. I mean, if you're good at cycling, that's the main part, is can you get those gears there rather than like, I think, manipulation.
So I mean, the other thing we talked about this actually last week as a group a little bit is that probably week 1, 2, and 3, if you have a gear mechanism, we're in the district model, so it might be different than some of the areas. But if you have a gear pickup in probably weeks 1, 2, and 3, you will rank probably pretty high. Don't know if you'll rank number 1, but you will definitely be one of the first picks. I think in get to Michigan State Championship, it'll be very similar to the low bar. At the Michigan State Championship last year, you didn't need to have, I mean, look at Rush, who won the Michigan State Championship. They didn't have the ability to go through the low bar because at that time, it was not necessary anymore for every single member to have that feature. And if you're dropping gears at MSC, you're not having a good day anyways.
I agree with that. All right, so we're going to take one last question before we head out. This is a really important question here, coming from the Twitch chat, as you can expect. So this is Dean Kamen's Denim is asking, are 4488 and 2337 building twins this year? We noticed we got some apparel, maybe some cross promotion.
No.
No,
we don't even keep in contact with them. If we do build twins, that'll be amazing.
Yeah, that'd be awesome.
Okay.
No, a lot of our students wear different team shirts all the time, and it just happened to be the shirt that Gus was wearing today. So
I got this from Worlds.
So, but no, we are not twins.
Yeah.
But hey, if 4488, if you want to send us your CAD drawings, we can take a look at it and compare.
Yeah. Share. All right. Maybe they should just watch Check-In. Speaking of that, we're thank you guys so much for being here tonight. We're going to move on to our next team. It's going to be Team 3847 Spectrum. They're from Houston, Texas. We're gonna take a very quick break and bring them right back. But Engine Nerds, thank you so much. We hope that your robot gets driving for this weekend, and we hope that your chairman's essay turns out good.
So do I.
Yeah.
Oh yeah, I have no doubt. So, all right, have a good night, guys, and we'll see our next team in just a moment. Thanks, guys.
technology demo for the Gridiron Challenge at the Texas Southern University. And right now, Spectrum is demoing 2 of our robots, and we're showing our football robot from the NRG Football Challenge.
So this is in the process of building our climber. We're just going to go simple. We're thinking that the easiest way to do it is simply at the end of the match, run the climber off of one side of the drivetrain. And so essentially just keep going forward. You want to start off the ground, just go forward on it. And we're not going to be using any gears, or initially we're not planning on using any gears along to gear it down. We're just going to run it directly off. Right now, this is the mid-stage of our climber. As you see, we put on the 2 posts. We have a rod that the strap will be wrapping around in the giant bag. We have giant bag with sprocket right here. That's going to run directly. It changes run directly from this sprocket to the powertrain. 875. Deanne said that these were half an inch apart, and because I don't want to measure it, they're half an inch apart.
That was like really long and hard.
All right, here we go. Can't wait to start the video, guys. First, I'd like to welcome to check in here. We've got Team 3847 Spectrum. They're from Houston, Texas. Gentlemen, why don't you introduce yourselves for everybody?
Hello, I'm Alan Gregory. I'm the head coach for Spectrum.
I'm Will. I'm a senior and I do mechanical design and chairman's.
Cool. All right. Well, welcome to the show once again. Good to have you all on. Let's get right into it. So we saw a little bit of your climber there, and we saw a lot of awesome stuff with your demo robots. Let's talk about those actually really quick before we jump into the other stuff. It looked like you guys had a robot that throws footballs, and it looked like it was modeled after Brock Osweiler with its particular wobble.
So it's a little out of tune, but so that was actually for the NRG Robot Football Showcase that was held in September of last year. So they challenged 4 of our local teams to build punt, pass, and kick robots, basically.
Oh, cool.
But this weekend we were out at the Gridiron Challenge. It was like an event for kids in preparation for the Super Bowl that's coming to Houston. So there's been a few different things that are going on. So having a football throwing robot is nice for that.
Nice. That's awesome. We spent
our Saturday morning out there doing a little demo, getting kids excited about robots.
Cool. Well, Tom Brady's in town. Just have him take a look at it. I'm sure it'll make it fun. No, sorry, I couldn't help. All right, so let's get talking about the robot stuff. This year's robot stuff.
Absolutely.
First thing we want to touch on is your CAD model. Now we've heard that you got a full CAD model.
Yeah, and so we're gonna go ahead and switch over to that now.
What?
All right. So we should be in our CAD model now.
Oh, there you go. Wow,
Yep.
Look at that.
All right. So this is pretty much the entire robot as we're about to send all of our sheet metal off to our sponsor tonight. So we have all of our subsystems in. We have our people producing drawings and stuff for it. But so basically the main concept is this guy folds up mostly. There we go. All right. So that's roughly starting configuration. So the balls get intaked. The mechanism intake will come down. There'll be more wheels on it. That's just how it's modeled.
Right.
And they get sucked up through the belt path here, and they'll all be stored in the hopper along these bottom belts. The belts aren't modeled in CAD right now, and fed back into the shooter, which is in the tower in the back. Yep. So then we'll have the 3 balls wide coming up. They're all in a line, so each path are completely separate.
Okay.
So we'll actually have 3 different paths of balls coming out of each one of these little shooter hoods right here.
Wow. So this is a fairly detailed CAD model you've got your robot going on here. You've got all the way down to the blinking light and the radio and the
yeah, absolutely.
Yeah, because this is basically the final version of our robot. So we have to make sure that everything fits. So if I didn't put the RSL light in and I didn't know that it fit, we just might not have an RSL light get cut out by our sheet metal sponsor. We'd have to drill a hole and put it in somewhere random.
Right. So I got to ask. So there's a lot of holes already in the sheet metal. It doesn't leave a lot of room for more holes, I guess, if you have to make modifications. When you guys are in your final assembly or getting it from the sheet metal sponsor, how much work, let's say extra CAD, like outside of the CAD, has to happen to the parts?
Very little. The goal is to have everything. So even to the point of like these holes you see here that are like basically lightning holes in the side of our climber plate those are like backup plans on backup plans. Like this is a roller shaft that can be belted to this roller if we need to add like another roller to our elevator system.
Or we could just mount a VP onto the side of the plate.
These are versaplanetary mounting holes here. So if we need to power the climber separate from our drivetrain, we could mount in a versaplanetary and chain up to this. So it's already CAD'd to the right chain spacing and everything. We don't want to do any of those things, but if we have to, it's ready to go.
Yes. Wow, that's actually very, very interesting. So I know that this will be like the third robot you've built for the season, basically third or fourth or what have you.
Yes.
I guess the thing is, why so much detail? I know that you want to not have to drill so many holes, but is it that hard to get? I don't know how your sponsor works necessarily, but is it hard to get more sheet metal parts from your sponsor later on in the season if you have to, say, make a new upright there that the climber rests on? Or
yeah, it'll definitely take more time, and also some of the changes we may not know about them until Thursday at an event, and we don't have time to make sheet metal changes then.
That's true.
But we could make the climber change. If we realize the drivetrain thing isn't working, we just need to throw a sim on a versaplanetary into there. We could do that in an event in 20 minutes.
Wow, cool. So as we're kind of looking at this model, let's talk a little bit about your sheet metal process and your drawing. So you said that you're sending it out to the sponsor now, and you're also making drawings for everything. Can you kind of explain that process to us?
Sure. So basically, once we know all our geometry and we're ready to make our part, we start making the sheet metal part. We put things in assembly, make sure everything fits together. And by usually around this time, maybe a couple days later every season, when we think we have something that's final, we're getting close to our deadlines for when we have to start setting things out for powder coating and start assembling our practice robot. We call up our sponsor and say, hey, we're gonna start sending you some parts. Are you guys gonna be ready for us? And then the next step is these drawings. So these are the drawings that the actual laser cutting, the laser cutter and the CNC brake operators are going to look at when they're making these parts. So they're looking for, flange lengths to determine setbacks. They're looking for how big these parts are so they know where to put the fingers on the CNC brake. They're looking at, making sure we have the correct radii, we have the correct materials, we have the, what die we're using in their brake.
Okay.
All of that information is necessary for them to be able to properly punch in the information in the computer so that we get accurate bends out of the brake.
Wow.
And so in addition, we send them the actual drawing files and the actual 3D model files. We then send them a PDF of this as well, so they can just print them off easier. And the DXF files, which are the flattened sheet metal parts that they actually put in the laser to do the cutting.
Oh, okay. I was going to say, you got to send them a flat pattern at some point as well,
Yes.
right? That's cool.
Yeah,
Wow.
So we send them 4 files for every single part that we want on the robot.
So that's a lot of documentation for all those different. I mean, the robot doesn't have a small number of parts for sure.
This one's about 40, a little under.
40 custom sheet metal parts. Yeah.
Yeah,
like
that's a good amount of like drawings to make.
And we make them all in the last 3 days. We started Sunday.
Well, I mean, sometimes you got to crunch to put everything on the mill. Sometimes you got to crunch to then get it through SolidWorks. So how many folks do you guys have working on the CAD? Because that sounds like quite a task, especially if you're not, doing this full time necessarily.
We
we have 6 subsystems
and 5 people doing CAD and drawings, not counting myself.
Wow.
So every subsystem lead for the most part will do their own drawings. We had one, so the guy who did our drivetrain also did the CAD for our climber. But that had the guy you saw in the video talking about the climber, he didn't do the CAD, but he did a lot of the physical testing and working out the geometry for us.
Yeah.
Wow. All right. So let's talk about your gear intake as we sort of see that on the model here. So it looks like it's kind of above where your ball intake is. Let's talk about that system, because that's kind of probably the most different part of this robot compared to other robots we've seen so far.
Yeah, so we're definitely going through a ground intake. We think it's going to be very important. I know you've been asking other teams. one of the reasons we think it's really important is at the beginning of the match, there are 3 gears already near your airship, the 3 that your team starts with, and you may not have partners who can score them. So if you can just set them on the bumper, have them drop them, and then pick them up and score them, that's going to cut your cycle times by a lot. So having a gear intake is going to be really useful.
Cool. So how does yours work? Give us the skinny on what this is.
So we were partially inspired by things like 2011 tube intakes and 2013 floor frisbee pickups. So we knew that there are ways to like lift something up and put it underneath a top roller and pull it into ourselves. So we went through a couple different revisions. There were times where we were working with a single long roller and like some plywood, and then we switched to the carbon fiber you see now, and we've also had like side rollers. But basically, the geometry you see here, we figured out, I think, starting Friday night. It started off with a couple drawings on the whiteboard, and then we put them into SolidWorks and started testing parts. But the idea is that the carbon fiber you see is a little bit ahead of the bottom of the wheel, so that the first thing that it really hits is the carbon fiber, and then the wheel starts compressing. And then hopefully that kicks it up off of the carbon, up onto the carbon fiber, and can just yank it back into the intake.
Oh, okay. So with this, how do you put the gear onto the peg? Do you just sort of put it on top and reverse the roller, or how does it go?
Yeah, basically. So it just rotates back up, and then we run the peg in, and then reverse the intake, and also tilt it forward so that we're pulling out as we're pushing the gear out.
Yeah, when this is stored in the robot, when it's vertical, this line right here is about 13 inches off the floor, which is the bottom of the peg. We can tilt it a little forward to make that hole come in a little bit easier. And then we just drive all the way in, start tilting down and ejecting, and it just puts it right on the wall.
Oh, okay, cool. That's awesome.
There's also, we've been testing, we haven't have to do it on the real one, but we believe we can pull it out of the loading zone with this as well. So our mechanism intake that you saw at the top of the robot will actually knock down the gear. And if it all works in the geometry that we want, the gear will fall into that intake.
Awesome. All right, so let's talk about all the little details, because it looks like you guys have from like a big perspective just about everything all set. So what are those little tiny problems you guys have run into so far?
So some of the things that we like make sure that we add, especially in this year. So these, the holes right here, those are going to be handles. So there'll be mounts on top of here that will screw on that will 3D print, because you have to be able to lift your robot off of, it may be in the middle of the air. You're probably going to lift it to be able to pull the rope down. So we want to make sure that we can be able to manipulate this robot very easily. And you're not going to be able to lift under the bumpers this year on almost anybody's robot since they're so close to the ground.
Right.
So we're making sure that we're catting in and making special sheet metal handles.
So we had tried steel cord back in 2014, but those just ended up like tearing out because we were securing them with rivets, and they weren't the most comfortable things to hold. Right. So we're hoping that we can 3D print some ergonomic grips onto these, so that it'll be a little bit more comfortable in the hand and a little bit more robust throughout the season.
That's awesome.
Yeah, so a couple other details. So back here, we have a slot in the back of our bumper because our PDP is so close to the back rail that we wouldn't be able to put the wires. We wouldn't be able to get a screwdriver or tool in there without that. So we have a slot that lets us get into, if we need to do any maintenance on them, we don't have to take the back rail off or anything.
Well, that's good. You notice that now instead of when you're trying to build the robot.
Yeah, we've tried to think through all the maintenance stuff that we possibly can. There's still going to be stuff we run into, but a lot of it that we've thought in through. Do you want to talk about the back panel?
So this is our back panel. This is something we really started doing in 2014 on our robot infrared. But you'll see in the bottom left, we have a couple cutouts for Ethernet and USB pass-through, so we're not reaching into our robot to get to the RoboRio for programming. And then down the middle, we have slots for little tiny inline automation direct gauges and regulators for pneumatics. And then to the right of that, that's our pressure release valve. And to the right of that is a little cutout for a voltage display, so that we can just check battery voltage by eye while looking at the back of the robot.
Oh, wow. So really all of these things, even though they kind of look like empty holes, they all have a purpose and a job.
Correct. Oh yeah. Yes. Even the weird TIE fighter patterns, those help us save the ounce. Those help us save ounces.
Yes, got to have them lightning holes. Cool. Well, let's take a question from the chat. Again, if you guys have questions for Spectrum or for any other team we've got on check-in, just type them in the Twitch chat with !Q, and we'll ask them to these guys. So we got our first question coming up here. How do you guys keep balls from jamming, especially with a 3-ball wide ball path?
So part of this is if you if we go pop back into the CAD model, we have a single red Andy Mark 2-inch wheel, and so that'll help balls keep from getting blocked in front of our shooter. Hopefully,
yeah. So then there's one in the CAD. There's going to be multiple in the real one.
It's going to be a whole roller. But then they're partitioned into 3 lanes. So each ball gets held between 4 belts, and it's a unique set of 4 belts for every lane. And we're going to have Lexan dividers in between them. So the balls shouldn't be hopping off their belts. They shouldn't be, commingling between lanes. And they're about, I think there's about a 1/4-inch spacing in between them. So it shouldn't be too hard for them to not hit each other in the air. But then down below, we also have specific belt paths for each lane to help sort of funnel them more into a direct lane, I guess. And the plan is also to sort of, we're going to find some way to agitate our hopper a little bit, shake it up. That might just be running the mechanism intake against the hopper side and have the little rollers banging up against the Lexan to shake it a little bit.
Yeah, because the things that aren't in the CAD are the Lexan panel. So there'll be Lexan going right up behind the mechanism intake, and the mechanism intake will basically push it back when it's actually stowed. And then there'll be Lexan across the side rails as well to hold all the balls in.
Awesome. Well, guys, it's always a ton of fun to hear from you. I'm glad to see that your progress is this far along. I can't wait next week to see your finished robot. Right? I don't know. No.
We'll probably hopefully getting parts back. Hopefully.
Okay. All right. That makes more.
Next time you check in with us, it should have been Sheet Metal Christmas. So
Sheet Metal Christmas. Well, speaking of Sheet Metal Christmas, the next team up on our schedule is Team 148. 5803. My bad. Team 5803 is coming up next. They're from SeaTac, Washington. They're Team Apex. They're going to be joining us. But for right now, Spectrum, thank you guys so much for joining us. It's always fun to talk to you, and we hope you have a great Sheet Metal Christmas and a great sort of build and all that with your awesome looking robot.
Thank you.
Thank you.
Well, bye for now. We'll see you guys in just a second. We are back, everybody. Here at Check-In, this time joining us is Team 5803, Apex Robotics. They're from SeaTac, Washington. Welcome to the show, guys. Can you just introduce yourselves for everybody?
Sure. I'm Jonathan Schaefer. I'm one of the student leads on the team, and I've also been doing animation.
Hi, I'm Jennifer Hogue, and I'm the documentation student on our team. And
Cool. Awesome. Well, glad to have you guys on the show. It's good to talk with you about your robot and all the awesome stuff you're doing. So we're going to get to the animation stuff, I think, in a little bit. But first, I kind of want to talk about the robot because we just saw that on the video. So let's first talk about your gear prototype. So it looked like you had a robot driving around. We'll get to that. So maybe we should talk about the assembly first. It looks like it's been basically building your robot this past week. Is that about right?
yeah, so basically we've started out building our practice robot. And so we cut all the parts, both for our practice robot and our competition robot, but we build our practice robot first. And so the pictures that you saw at the end of the video, that was our completed drive base for our practice robot. And then it also had a little piece on there that's for the shooter. And so we completed that. Yep.
Nice. So did we see the practice robot driving around as well, or is that last year's robot that you guys modified?
Yeah, that was Party Stalker.
That was Party Stalker. Okay, cool.
So driving around with the gear on it. So yeah, we've been using that to test the prototypes. We don't have the practice robot in driving mode yet. Okay,
cool. So I'm not terribly familiar with a lot of the tools necessarily you were using to put your robot together, because it looked like there was a lot of these weird looking rivets coming out of it and a lot of brackets and stuff. Can you sort of give me the skinny on how Apex builds robots and how they all come together?
Yeah, so we use a lot of the Versa frame, the 2x1 box tubing. And so basically that's really helpful for us because it has holes that are all spaced out equally in the box tubing. So we cut everything based on those holes, and then we're able to just put brackets and rivets right in those holes, and it goes together really nicely if you cut it right. And then, so yeah, we use a lot of rivets and also a lot of bolts for strength, and a lot of the box tubing is how we build our structure. It's also really light and really versatile to use.
Okay, cool. So there's not a lot. You don't weld the frame, and you're not. A lot of these parts you're cutting sort of in your own shop without the use of a mill or a lathe. Is that right?
Most of the parts. We got quite a bit of help from sponsors. C4 Labs down in Tacoma, they cut a couple of our, for instance, like shooter plates and stuff like that for gearboxes, stuff that we kind of needed extra support for, that those plates help give. And so those had to be machined.
Okay, cool. So what about, we saw that there was a huge sheet of these brackets. Were those part of the ones that C4 made, and what are they the shooter plates or the other parts?
So those are they talking about the red brackets?
So like the parts that cut.
Oh yeah. So some of the stuff is cut by C4. Some of it is just stock brackets. But the stuff that was beefy looking and looked like it was cut by a CNC was cut by C4 Labs. Yeah, it definitely varies. We kind of mix and match depending on what we need.
Yeah, and we went down to their shop. They've been really amazing, and they trained a couple of our mentors to be able to just go down there and use the tools whenever they want. So we don't need them there. So I wasn't there, but a couple of our students and the mentors stayed there till about midnight the other night, cutting all those brackets.
That's awesome. That's a great sponsor to be able to do that. That's really good to hear.
Yeah, it's been amazing.
So the other thing I kind of want to talk about that, and this is really just because I'm really curious. So there are these really, really big looking like rivets that were in the frame when you guys were using your air powered gun to put all the pop rivets in. What are those?
So mostly those are for putting our drivetrain together. We made it so that all the outside of the bumper frame has countersunk rivets. And so they all sat nicely on the frame so that we can get the bumper flat and properly secured.
Are you talking about the clamps that we have?
They were big and like brownish, like really
Yeah. So those are clamps that we use to hold it together, just temporarily. Yeah.
Oh, okay. So are they clamps that go into the holes in the frame?
Yeah, Cleco clamps.
Got it.
So those the big colored things. Yeah.
Nice.
Yeah, so I got you now. But the Cleco clips, basically they're temporary rivets. So we can put them in, and then we can put like most of it together to see if it fits and see how it fits together.
Yep.
And then once we like it, then we take them out and put real rivets in.
I see. All right, cool. So let's talk about that gear prototype. We saw a little bit on Party Stalker. It looks like it's holding a gear. It looked like we had some manual action to deliver it. Tell us the story behind that.
Yeah, so that prototype started back when we were doing our prototype stage, and we've kind of retrofitted onto Party Stalker, and we're trying to go for, of course, as low profile as possible because of the size limitations of this game. So, I mean, I wasn't personally on the team for the gear. I think, yeah, she knows more than I do, but yeah, we've kind of gone through a process to get it in.
Yeah, so it's been quite a process. As you saw, the first like clip, it showed us failing, like we kind of pushed the gear away. But then the next couple clips, we've kind of figured out how to drive up to it, and it just sucks it right in. And so basically, we also tested a lot of different wheels and rollers to put on it. And we figured out that the black, like, I don't know what you call it, but it's like the tube of sticky material, and that held the gear the best.
Yeah, like rubberized material.
Yeah. It gets sticky.
Yeah,
It's
and
very grippy.
we wanted to put it on Party Stalker because we wanted to see if it was possible to drive up and pick up a gear in that little of a like space.
Yep.
And just to see if it would hold it with the geometry that we decided on.
And what were your results? Do you think it's good?
Very good. It was inconsistent because it was made out of wood and the polycarb was bent, but besides that, it was very good results that we hopefully going to use on our robot.
Cool. So kind of talking about that, you're not going to make your real robot out of wood. And as a second-year team, I know that you're trying really hard to make your whole thing look good. What kind of swag are you guys doing to make sure your robot looks like it's made by pros?
Well, so last year with Sub-Zero, we had the red brackets, and they were just spray painted multiple times, and we put them on there. And I'm happy to announce that those will be making return. And so that's just something that kind of adds a little flair to it. And another thing we do is we use a disc sander, a handheld disc sander, to sand down the pieces, the Vex Pro VersaFrame that we use. And it kind of gives it this nice sheen. It's kind of shiny.
Sparkly.
It sparkles, and it makes it look a lot nicer. It doesn't have a lot of scratches and stuff in it.
Yeah, something that we always say is that there's nothing that goes on the robot that shouldn't be there. Like everything should have a purpose and should look like it has a purpose.
It's always good when it looks like it's supposed to be there, not sort of like, oh, I gotta put this on. So cool.
Yeah.
Duct tape.
All right. Yeah. So we're gonna take one question from the Twitch chat before we go to the animation and talk about that really quick. So let's, again, if you have a question for us, just type !Q in the chat and we'll get it into our system. This question comes in. What do you guys think your biggest technical challenge so far this year has been? Especially because you guys are a second-year team.
Biggest technical challenge, I mean, we don't have a lot of the resources. Still, I mean, we have a lot of great sponsors that can cut parts for us, but we still don't have, in-house CNC or, any mill. And that's been kind of a challenge, having to kind of wait for parts to come in. And I mean, they've been doing a very good job of getting them, quick, but there's only so fast you can go. So that's a challenge we run into.
Another thing is,
go ahead, Jamie.
Yeah, so I think it was 2 weeks ago, we had about half of our school was sick. And so we only had 3 or 4 students at a couple of the meetings, and so that was really hard. And then the next week was finals week, so students were taking time to study for finals, and so student attendance was definitely an issue for us.
Well, I'm glad you guys are behind that, hopefully. So that's good. So let's talk a little bit about the animation here. So I know that you've been working on it. Why don't you tell us? We'll show it here as we sort of end your segment here. But why don't you tell us a little bit about the animation award this year and what you've been up to and how you've exactly done it?
Yeah, so I was told that the animation award came back this year by one of the mentors, and I was pretty happy about that since I have been doing 3D animation for a while and 3D modeling. And so I started back when it was first announced, which was in probably, I don't know, last year sometime. And I started on it and I started working a lot. And I've been using the robotics practice or the robotics meets to kind of keep working on it. It's just been a lot of grinding on it, a lot of a lot of work, just meticulously kind of modeling each part and then texturing it. And I tried to use as much stuff that was original as possible. So a lot of the textures I took myself, but I mean, it's been a challenge to complete it, definitely. But the biggest part was probably staying motivated and keeping going like every week on this thing.
So a lot of that stuff in the you'll see the animation in a second. A lot of the stuff in the animation looks like it's new. It's definitely like the balls are definitely a recent part. How much of the animation do you think you've actually done in the last like 3.5 weeks?
Probably the majority. I had created stuff like the main subject and probably the starting scene, and then as it developed, really the first shot where the lights are off. That's the part that I had before build season started, and then at kickoff I saw the balls and I started just working on the whole shot. Yeah, and you'll see it, but yeah, I did not have much done before, but I had my ideas laid out and I had a script and I kind of went off that. So.
Yep. Okay. Yeah. I'm definitely going to say we're going to show it as we sort of go out. But it what you're saying definitely shows true. It's got a very great script. It's very well voiced. It's very tight. It's very dynamic. Not a lot of like moving to different scenes, but everything has got something going on in it. So it's always very compositionally great, and also it looks wicked good. So well done with the animation there. I'm very impressed with it. We're gonna show it here. Do you think this is gonna end up on YouTube in the next couple weeks?
Yeah, it should end up on YouTube pretty soon.
Cool. So we'll also link to the YouTube video of it here. If you're watching not live, we'll link to the YouTube video so everybody can take a look at it after the fact as well. But we're gonna say goodnight to you guys, and we're gonna outro with your animation. Up next, for real this time, is Team 148, the Robo Wranglers. They're from Greenville, Texas. But for now, goodbye, Apex, and let's take a look at Apex's submission for the Animation Award this year. Bye-bye, guys.
Bye.
Steam. Steam is all around us.
All right,
It powers
sounds good.
turbines, cooks food, and hangs over humanity's greatest fuel, coffee. But steam is so much more than excited wonder molecules. STEAM, short for science, technology, engineering, art, and math, can also be produced by excited students. Students excited to be participating in a program that can help shape their future and sharpen their skills. These students will become scientists, architects, engineers, teachers. They will become the backbone of the next generation. This is why FIRST isn't about robots or trophies. FIRST is about so much more than that. Through STEAM, FIRST seeks to enable students to win their own battles, grasp their highest potential, and reach the apex of what they can truly become.
All right, we're back, and it's time to talk to Team 148. They're the Robo Wranglers, and they're from Greenville, Texas. Welcome back to the show, folks. Can you guys introduce yourselves to everybody at home?
Sure. I'm Adrian Emerson, lead teacher of the Robo Wranglers.
Hi, I'm Madison. I'm a student leader and on the CAD and design team.
All right, awesome. So we got a lot of awesome, really cool things to talk about. First off, I kind of want to talk about how your build is progressing. It looks like you guys had sheet metal Christmas, basically. It looked like you had all sorts of stuff show up at your shop. Tell us about how the build is progressing so far.
Yes, we had part of our sheet metal Christmas on Friday. We got all of our drivetrain in, and then last night we got part of our new intake in, and then we're hoping to get the rest of the sheet metal on Friday.
Awesome, that's great. So from between Friday and you getting all the sheet metal for your drive line, how long did it take you guys to actually have a fully working driving part of your robot?
So we stayed late on Saturday, and by about 11 o'clock we had it up and running on the field. So that was really exciting to see it finally move.
That's great. So you had like almost nothing, and then you built the robot and had it driving in like under 24, 48 hours?
Yeah.
Yep. Lots of hard work. We stayed a little late on Saturday too, but we couldn't leave without seeing it move.
Oh yeah, I know that feeling. Did you guys have like all the electronics pre-built and you just kind of drop it in, or did you have to wire the whole thing up as well?
Yeah, so we got the electronics boards back on Tuesday so our Sparkies could actually start wiring them. So they were pretty much done and just had to be dropped into the drive base.
Okay. And Sparkies is a term for the electrical guys, I guess?
Yes.
We forgot to tell you that like we speak our own language over here, so you got to call us out when we say funny stuff.
Well, it's just funny. That's all. I've heard of snurps before. I didn't know Sparkies was also a term too, but cool.
Yep.
All right. So let's also talk a little bit about this other stuff we saw in your video. So we saw an intake without a picture of a chainsaw over top of it, although it was mostly a cardboard box. How is that kind of the design you guys are going with for your sheet metal build right now, or is that a previous design?
That's a previous design. The new design is very similar to it, though, just a couple revisions.
Okay, but it's not made of cardboard, I assume?
No, we're just testing.
Okay, very cool. Awesome. Well, it looked like it was working really well. We also saw a lot of video there of you guys building and assembling and putting together like a full field. Why don't we talk a little bit about how you guys been doing that?
Sure. We've spent a lot of time and probably had a good 10 students and maybe 3 mentors dedicated to field building for most of our meetings. But we, I think, can call it done for right now. The only thing we're missing is one of the boilers. We actually worked with Team 3310 from Heath, Texas. They're about 20 minutes down the road from us. So we worked with them in building the field. So they actually built both of the boilers. So they built one for us and one for them. And once competition season starts, they're going to bring that boiler up and they're going to practice up at our facility. But the airships are done, even though we call them tree houses. And they look really good. And everything else, I think, is in place. So we've actually moved that sub-team to start working on getting old drive bases up and running so we can start using those as defense robots and things like that for eventually down the road when we're ready to start practicing.
Oh, cool. Wow. So you're already getting ready for your driver practice, and you're this far ahead, basically. Not ahead necessarily, but you got that many resources to do it. That's great. That's awesome.
Yeah.
Cool.
Yeah, we have a lot of kids on the team this year, more than we're used to. So it's given us a little bit of flexibility to do stuff like that.
Very cool. So let's talk a little bit about your shooter stuff. We know that we didn't see any footage of the shooter this week. We saw a lot of boxes previously. But we know you guys have some updates to talk about, not about the shooter in general. So what's up with that?
Sure. Madison was saying we're hoping to get some more sheet metal on Friday, and that is more of a high fidelity prototype of our shooter. We're pretty sure we've narrowed down some of the basic design features of the shooter. So we're going to knock out a high fidelity prototype for Friday and then test it this weekend to make sure that we're absolutely sure of the direction we want to go with the shooter. So we're hoping to drop sheet metal for that in the morning. So send it over to our manufacturing IFMI, and they will hopefully get it back to us by Friday, and we'll work with that. So we said last week, that's kind of the subsystem where we feel like we might be a little bit behind on. So we're still working, and just we feel like investing the energy to prototype this 3 or 4 times is really worth the investment, because if we can invest all this time in prototyping, then the final design should go into place pretty easily, and we won't have to make many modifications. So
cool. So when you say high fidelity prototype, this is like you've basically taken all your other prototypes, figured out what works, what doesn't. You've CAD'd it, and you've gotten it in a drawings created to send it off to have made. How long does that process take? The sort of the CAD to the drawing to the sending it off to manufacturer. Is that like something you could turn around in a day or two, or does that take like almost like a week, or how does that work?
No, we started CADing the shooter about Saturday or Sunday.
Okay.
And our CAD team worked on that basically all weekend. And there's still a little bit more to go. For this particular prototype, we're not going to do any of the finishes that we would do on a real robot, no lightning, or trussing patterns or anything like that. We're just going to get the basic design out and throw it on a robot and make sure it works. And then if we're happy with it, then we'll go back and do all that other stuff. So again, normally we wouldn't go into this much detail with a prototype. We would say, hey, this is going to be good enough. If we have to make we'll make it a final design, and then we'll tweak as necessary. But like I said, this shooter, we just think it's important enough this year that we need to invest a few more steps in our process to make sure that we get it right.
Cool. So I guess, best guess from you guys. Do you think it's going to work almost completely the way you want, or how much modifications do you think it's going to take between this and your final shooter?
Ooh, that's a tough question.
I feel like it'll probably need some modification.
Yep.
Because it's been kind of difficult. This has been our slowest group, this build, so just trying to tune it in so far.
Okay.
The thing we've prototyped the least is probably the feeding, and so I think that's what we're most worried about. So I think that's what we're probably going to have to tweak with.
Okay, cool. So does this prototype also include the mechanism that brings the balls into the shooter, or is it just a shooter mechanism?
Yeah, it includes what's bringing it in. Plus, we are working on a hopper feeder system back at the shop right now that's going to go onto the drive base and then go in and integrate in with this high fidelity shooter prototype. So
cool. Well, that's awesome. I can't wait to hopefully see some video, maybe with some stuff blurred out, but it'll be really cool to see what this prototype looks like. So, or how it shoots at least. That'll be great. So let's talk a little bit more about the not robot stuff you guys do. So you guys have won tons of awards in the past, and you guys are already starting to work on some of the awards. Why don't you tell us a little bit about how that's all going?
Yes, so we've been working on chairmans since this fall. Yeah. And this past week, we've been hitting really hard on the essay, and we're close to having it done. Got to make final edits, and then we've pretty much done our questions that go along with that, and we're hoping to start our videos sometime this week, and then we're going to start working on the presentation on Saturday.
Wow, so you guys are pretty far ahead on that. So when you say you've been working on it since fall, we know we've known that the chairman's essay is going to be a thing. It's not like it's a surprise for anybody. How many hours do you guys have put into this essay?
Oh man, a lot. A lot. We worked really hard on our chairman's submission last year, and that was me and Madison's first experience on the Chairman's Award team was last year. So we worked really hard on this last year, and we kind of came in and we felt like we had a little bit more experience this year. And it's been really fun to kind of see the progression that we've made. One of the other mentors was saying today that he thinks that the essay looks really great, and comparing it to last year's essay, it has like so much more substance instead of like less fluff.
Yep.
And we were really excited about that. And it's just fun to see how far you can come in a year. So.
Oh yeah. I mean, people tend to see the essay as something you have to fill up words with, and really, if you're a team that can earn and win the Chairman's Award, you shouldn't have any problem putting a lot of great stuff in there. And that's great to hear you guys are doing that. That's awesome. So
yeah, it's been a really fun process.
What about the other awards you guys are submitting for? I know that the Woody Flowers Award deadline is coming up pretty soon as well. Have you guys been working on an essay for that too, or?
Yeah, we have a couple kids that have been working on it. They have a rough draft. We're, of course, like any Woody Flowers team, over characters, because that's the hardest part of the Woody Flowers Award.
Yep.
And I've been helping out a little bit with that sub team along with 3 of our students. And I think that it's coming along really well. We, have a lot of great mentors that are all really, really deserving of the nomination. And so I think that this year it's a really great nomination. And no matter what happens, it's really great to recognize your mentors in that way.
Oh yeah, I totally agree. I was lucky enough to have 2 mentors on my team when I was growing up that both have won the Woody Flowers Award, and I was happy to help write one of their essays. And it's unlike the chairman's essay. Sometimes that one's always really, really hard to boil down to just exactly what you're supposed to have. So that's really good to hear.
Yeah.
So I also heard you guys. I think I saw some of your FedEx Challenge stuff. Are you guys also trying to submit for that? And what is that exactly?
Ooh, I'm going to give you a rough summation, but neither of us really work with the sub team that's doing that. So we'll try and do our best for them. But the FedEx Challenge is obviously sponsored by FedEx, and there's a lot of prizes that you can win. There's 3 different challenges. I do know that. So one of them was to steampunk your logo, which we did, and we posted that on our social media.
Yep.
The next one, which we still haven't posted, but we're finishing up, is I think it was something about opening up the kit of parts, something. And then the last one is talk to a first alumni and get some information from them about their experiences. And so we have our mentor, our coach, Kevin Morris, is going to be part of that submission. He was a 148 student when he was in high school, and he's been a mentor for a really long time for us. So he's going to do that part of it. So
wow, that's awesome. That should be fun. Cool.
Mm-hmm.
All right. So let's take a couple of questions from the Twitch chat. We know that you guys are trying to keep some stuff secret, so we're not going to ask anything too prying. We also are going to try to rephrase them sort of like a yes, no, if possible, because not everybody in the chat asked them. But if you have a question for these guys, type !Q followed by the question in the Twitch chat, and we'll send it in. If we like it, we'll ask these guys, and we'll get an answer from them. All right, so we got our first question coming up here. All right, the drivetrain looked small. Did you choose the tall volume for your robot?
No, we didn't. We chose the small, the short, I should say.
Ooh, really? Actually, I was going to remark the drivetrain it looks itsy bitsy. I mean, it looks really good. It looks like it performs well, but it's almost like when I first saw it against the carpet, my mind saw it and thought it was a Vex robot. I know it's not that big. It's definitely not like that, but it looks so small.
It's really small.
It's really small. It is really small.
Cool.
And this and meanwhile today we actually did a demo at an elementary school earlier tonight, and we actually put Renegade in the trunk of a Jeep. So Renegade was really small, and this robot is even smaller.
Cool. All right. So we have another question coming up here. This is also one that somebody asked, but we've rephrased to be a yes/no question. So can you guys hold more than 60 fuel? I mean, right now your robot doesn't hold any because it's got no hopper on it. But do you guys think it will hold more than 60 fuel?
Maybe.
Yeah, maybe.
Maybe.
Yeah, we actually don't. Yeah,
know.
We don't actually know.
Okay. So is it mostly just you kind of build it as you build the hopper as big as you can get it, and then whatever that is?
Yeah.
Okay.
We think storing fuel is important, but we also want to make sure all of our mechanisms work.
Yes.
So so we're gonna make sure everything works, and then we'll see how many our robot holds.
Okay, that makes a lot of sense. It's hard to shoot balls if you can't shoot them, and it's hard to store balls if you can't collect them. So that makes a lot of sense. Cool. All right, and we got one more question. Unfortunately, this was not a yes or no question, but we'll see if you guys answered anyway.
Okay.
Coming up next, it is from Azathoth __. What is 148's preferred brand of chainsaw?
A black one.
I don't. Is there anything? Is there such a thing as a black chainsaw? I feel like that's like.
I don't know.
Right? Like if you're in the woods, what if you drop a chainsaw on the floor? I don't know. Maybe. No. I bet you could make one.
All black everything, man.
All black. Is that like your team motto? I'm guessing it is because
Yeah.
Cool. All right. Well, hey guys, thank you so much for joining us. And by the way, to the both of you, thank you guys for driving to the IFI headquarters to do the show. We had some internet issues at the school, and you guys were great sports, and you drove to a different location. We put in Apex, and you guys came on board. So thank you so much for doing that for us.
Yeah, thank you guys for being flexible and having us on.
Oh yeah, it's always a bunch of fun. So everybody watching, thank you for tuning in to check in this week. We're going to have all these videos up on YouTube in the next couple of days, so you can send them to all your friends and check them out in greater detail. We're going to be live next week at 7 p.m. Tuesday, right back here on twitch.tv/FRC GameSense. We also broadcast on YouTube. If you can't watch Twitch, just go to youtube.com/FRC GameSense, and then follow us on Twitter and Facebook. We're both the RoboSports Network in those places. But ladies, thank you so much for joining us this evening. It's a lot of fun to work with you as always. And for everybody watching at home, thank you for watching tonight. We'll see you again next week. Bye-bye for now, though.
Bye.
Guys.